Samurai Kaizen presets.
Software Engineering Vocabulary 2. Agile. A project management methodology focused on iterative development and collaboration. Binary. A base 2 numeral system used internally by almost all computers and digital systems. Branch. A parallel version of a repository used in version control systems to develop features separately. Cache. A hardware or software component that stores data to serve for future requests faster. Class. A blueprint for creating objects in object-oriented programming, defining their properties and method. Cloud computing. Delivery of computing services over the internet, such as storage and processing power. Continuous integration, CI. It's a practice in which code changes are automatically built, tested, and merged regularly. Container. A lightweight, portable, and self-sufficient software environment that packages an application and its dependencies. Data structure. It's a specific way of organizing and storing data in a computer to be used efficiently. Dependency. It's an external code or library that a software project needs for functioning correctly. Deployment. The process of releasing and installing software to a production environment. Encryptation. The process of encoding data to prevent unauthorized access. Exception. It's an error or unexpected event that occurs during the execution of a program. Function. It's a block of reusable code that performs a specific task and can return a value. Garbage collection. Automatic memory management that reclaims unused memory in a program. Interface. It's a shared boundary that allows two systems or components to communicate with each other. Loop. It's a programming structure that repeats a block of code as long as a condition is true. Protocol. A set of rules that define how data is transmitted over a network. Recursion. A method where a function calls itself to solve a problem. Selection. The decision-making process where specific code executes based on conditions, commonly implemented using if, else if, or switch statements. Sequence. The execution of instructions in a specific logical order, one after another. It's the simplest control structure in programming. Unit test. A type of testing that validates individual components or functions of a software program, as it can be seen in the following pyramid. Quick quiz. Here we have the following words as class, CI, loop, dependency, and container. Each one has a definition. In this case, they're all scrambled. You gotta relate which is the right definition for each word. Pause the video, take a little time so that you determine which are the right answers. And here you go. This should be the right answers. Now, determine which abstract diagram corresponds to each concept. Loop, selection, and sequence. Take a time. Are you ready? Here we go. Perfect. Now, what is recursion? Take a time to think, what is recursion? Pause the video if you want. Try to make a little bit of memory. And then we'll continue. Done? Recursion is a programming technique where a function calls itself to solve smaller instances of a program until it reaches a base case, which is a stopping condition, that it's commonly used for tasks like traversing data structures, solving mathematical problems, or implementing algorithms. Here we have the following code. If you already know something about coding, especially in regards to Python, try to determine which structures are related to this technique of recursion. Pause the video if you want. Okay, so in this case, the base case, once again, is if, in which if n is equal to 0 or n equal to 1, it prevents infinite recursion by defining when the function should stop. Now, the recursive case is return n times factorial n minus 1, which reduces the problem size by decreasing n and calling the same function until it reaches the base case. So in this case, if you put that the number of n is actually equal to 5, then it's going to be starting multiplying the return n times factorial n minus 1. So it's going to be factorial 5 times factorial 4, then factorial 4 times factorial 3, factorial 3 times factorial 2, and so on until you conclude into the base case in which n is equal to 1. Because in order to arrive to arrive or to reach the n equal to 0, it's faster to get closer to n equal to 1 if we're going on this reverse count. So in this case, finally the result of the multiplication would be 5 times 4 times 3 times 2 times 1, which is 120. So this is a really practical manner of utilizing recursion, in this case for calculating factorial. Well, that is it by now. This is Samurai Kaizen. Stay tuned for more videos of technical English, especially in programming and in many other fields. Stay tuned.